Hello, calculus. Today we are going to learn about one of the really big parts of calculus, which is the derivative. Okay, a derivative has a definition, and the definition is math. Okay, so it's all about a limit. So we are asking you for the definition of a derivative. We're looking for a very particular formula, and that's going to be the one that we put here in the box. There's actually a couple different versions of the formula. One of them deals with the letter H, and one of them deals with a delta X. Delta means change in. This symbol, delta, is Greek. It's often used in physics classes. It means the change in. So you take like one X value and you subtract the other X value. It's also like the distance between two X values. All right, so this also is AP sections 2.1 and 2.2. The homework is only 6 questions. They are a little bit more involved than a lot of our other limits questions have been. They have several steps to them. Okay, so first off, we are going to be able to find the slope of a tangent line to a curve at a point. So we'll have to talk about what a tangent line is. And we will use the limit definition to find the derivative of a function. Okay, so let's talk about the derivative of a function. A derivative allows you to find the slope of a function at a point. Okay, so sometimes you have like a straight line and you can find slope using rise over run. That's easy peasy stuff that you've been doing since like pre-algebra. But sometimes we have a curve function instead of a straight line. For example, we might have a parabola. And let's just use like y equals x squared. Normal little parabola. If we want to find the slope at this point over here, that doesn't particularly make sense because slope is like rise over run, and we don't really have a rise or a run. We have a curve. So what you are going to end up doing is talking about a tangent line. A tangent line touches your curve at the one point, and it does not go through, but it like skims along the side of that point. Skims along the side of the parabola or whatever your picture is. So the pink line here is called a tangent line. We call this point right here, the point where they meet up, is called the point of tangency. We will abbreviate that with the letters POT, point of tangency. And our job on these problems is to find the slope of the tangent line. Okay, the slope is going to be SOT for the abbreviation. And then based on a point and a slope, we can use point slope form to find the equation of the tangent line. Right? That has like a y equals mx plus b. You can totally figure that out. And equation of tangent is going to be EOT. So you'll see those abbreviations quite a bit from me. They are not necessarily used by other teachers, but I don't like to write out lots of words when we can just abbreviate stuff. So here we go. We are going to go over what is the definition of the derivative of a function. What are those limits? So let's start out by figuring out how would we find slope in general. I'm going to use pencil on this, and then I'll end up erasing some stuff. In former classes, you have done problems where you have found like f of b minus f of a over b minus a. That is going to be your rise because it's the y values, and this is going to be your run because it's the x values. Now, h And the change in x, that means the difference between your two x values. So on our first fraction, instead of b minus a being the change in our x's, we're going to have h be the change in our x's. So h is the same thing as b minus a, and so is the change in x. Those mean the same thing. Okay, f of a is going to represent like your first point. So we're going to put f of x in that spot, and it's going to be f of x in both of them. Okay. But from one point to another, we are not going to have f of b. B is going to be represented by where we start, which is like your first x value, the one we actually care about, plus h, whatever the distance is between the two. So b is the same thing as x plus h. And we've talked about how h and the change in x are the same thing, so x plus change in x is going to be b in the second one. So it's going to be f of x plus h, or f of x plus the change in x. And just like how this one had a minus in it, this one will have a minus as well. We're going to take the limit of these fractions as h, which is the distance between your 2 points, your two x values. H goes to 0. We want our 2 points to be so close together that we're not actually doing two separate points. We're doing 1 point. So over here, limit as change in x goes to 0 as well. The distance between your x values gets really, really close to 0. There are several different ways how to write a derivative, and if you see any of these, it's the problem telling you this is either a derivative or it wants you to find a derivative. So first off, we know that f of x itself is a function. If we put one little mark up here like that, we call it f prime of x. F prime of x is the derivative of f of x. Okay. The next one is d dx. What this means is that we are taking a derivative where x is the variable that we care about. We are also going to put a little y on top. This means that we are taking the derivative of the function y with respect to x. So the two variables are x and y. X is the independent variable and y is the dependent variable. In kind of the same idea, kind of mixing these two together, if we have the function y and then we put a little prime on it, that also means the derivative. You would call that y prime. Next is d dx, so very similar to number 2, but instead of y, we're going to put the function f of x over here. So we're taking the derivative with respect to x of the function f of x. The last one does not show up very often in like a Calculus 1 kind of a class, but you could see it if you look up things on the internet to help you out. So the same kind of deal, derivative, where the variable, the independent variable is an x. So we're taking the derivative with respect to x of the function y, or that could be an f of x, same kind of deal. The most common ones that you guys are going to see are 1 through 4. I would probably never write it like this for you guys. Okay. This one shows up the most often, at least at the beginning, because we start with a function called f of x, and then we'll put a little prime on it to show a derivative. So let's find a derivative of a function using limits. So if the problem says using limits or using the definition of the derivative, this is the method you're going to use. So find the derivative of f of x equals 2x minus 3. So this is our function. It's a straight line, and it looks like this. 1, 2, 3. y-intercept is -3, up 2 over 1, up 2 over 1, and we can draw a straight line through it. And boom, there's our line. What is the slope of our line? Well, a slope is literally just rise over run. And since we have a straight line, we know that we go up 2 and right 1, so our slope is 2. We could also tell that from right here, the slope is 2. But we're going to use the definition of a derivative to find that 2. We're doing that specifically on this problem because we know the answer. In future problems, we won't know the answer, or the answer changes depending on where you are in the function. So we are going to be using this guy right here, the limit as h approaches 0 of f of x plus h minus f of x all over h. Notice that h is on the bottom of the whole fraction, not just under this piece. So we're going to copy this down, but first we need to figure out what f of x plus h is. Let's do that off to the side so we don't actually have to write out quite as much. So over here, I'm going to do some side work. F of x is 2x minus 3. F of x plus h, what that means is that everywhere we saw an x in the original problem, we're instead going to put parentheses, and inside the parentheses put x plus h. So this is going to be 2 times the parentheses minus 3, right? Everywhere we saw an x, put a parentheses, and inside the parentheses, x plus h. Okay, so we are substituting x plus h instead of x. Now, f of x plus h is going to equal, let's distribute, 2x plus 2h minus 3. Now that wasn't a ton of work here off to the side, but there will be problems, specifically the next problem, where x is squared or cubed or something. So we have some more effort to actually solving for this. All right, so I'm going to put this bit right here in pink, and it represents f of x plus h. I'm just going to copy down that limit definition from up above. It was the limit as h approaches 0 of, there was an h on the bottom, there's a minus on the top because we are finding the distance between two y values. So we had an f of x plus h, and then we have minus, and then let's do green for f of x. Alrighty, this limit equals f prime of x. Okay, and f prime of x is the slope of a function at a point. The derivative is the slope of a function at a point. All right, so let's just bring down that left side. F prime of x equals, we're going to have this limit for a while until all of the h's get plugged in as zeros. If you plugged in 0 right now, like we always try that first, right? Plug in 0. If you plug in 0 here, this pink bit would just be f of x, and f of x minus f of x is 0. And if you plug in 0 on the bottom here for h, you would get 0 as well. So there's a hole. So we're trying to take care of the hole by canceling out an h from the top and the bottom. We just have to get it to the point where we can cancel out an h from the top and the bottom. You cannot do it right now because h is inside a set of parentheses up here. Okay, so we know we're going to have an h on the bottom. F of x plus h was that pink bit that we did off to the side. It was 2x plus 2h minus 3. Then I'm going to put a minus. And then f of x is 2x minus 3. The parentheses are important because you are subtracting the whole function, not just the first piece. And now that we have put in that minus, we can go ahead and distribute it like a -1. So make it a plus, make that a -2x, and make that a +3. Okay, so spend the time actually going through and doing that I know you can do some of this stuff in your head, but show that it was a minus and that you're changing all of those signs. All right, bring it down. F prime of x equals the limit as h approaches 0. It's a super common mistake, partially because of habit and partially because of misunderstanding. All right, so we have some terms that can actually match up. We have a 2x and a negative 2x. Those combine to be 0. They cancel. All right, what else? 2h, nothing matches a 2h, so let's bring it down, 2h. Negative 3 matches with a positive 3 and adds to 0, so those guys cancel. So literally all we had was a 2h on the top, and we have an h on the bottom. This fraction simplifies, doesn't it? Could we try plugging in 0 right now? Heck yeah, let's try. Plug in 0. 2 times 0 is 0 over 0. 0 over 0 is that indeterminate form. We cannot do that. We cannot just leave it there. So we're going to do that thing where we cancel out an h. I'm going to rewrite one more time. F prime of x equals the limit as h approaches 0 of 2 over, well, when that h canceled, it became a 1. Oh, you can't see what I'm writing. There we go. So 2 on top, and then that was a 1h in the denominator. So f prime of x equals, let's take the limit of 2 over 1 as h approaches 0. So everywhere there's an h, plug in a 0. Oh, there's no h's anymore. So this just equals 2. So f prime of x, which means the slope of the function is 2. All right, I'm going to write out a little wording over here. The slope of f of x which was 2x minus 3 is 2 and is always 2 because the slope of a linear function doesn't change. Because the slope of a linear function doesn't change. Boom. Done with this page. This time we're going to find the derivative of f of x equals x cubed plus 2x. So that is a more complicated function than just a straight line. I have it graphed down here. It goes through 0, 0. It's a cubic function. It also goes through 2, 12. We know it goes through 2, 12, partially because you could just plug in a 2 and get 12. Another reason is because it says that it goes through the point 2, 12 over here. So a couple of ways we can figure that out. So we're going to start by finding the derivative of that function. So we're going to use that f prime of x thing that we used on the previous problem where it was f of x equals 2x minus 3. But then we're going to take this a step further and we're going to find the equation of the tangent line. Equation of the tangent line, I'm going to abbreviate as EOT, just like I did at the very beginning of the video. And for the equation of the tangent line, we are going to need like a y equals mx plus b kind of thing. We need the slope of the tangent line. We find the slope using the derivative of our function. We also need the point of tangency, and the point of tangency is over here. So we need a point and we need a slope. So EOT, anytime we're looking for an equation of a tangent line, we need two things. We need the point of tangency, which is given to you, and the second thing you need is the slope of the tangent line. So for equation EOT, you need pot and sot. Before we write out all of our f prime of x stuff, f prime of x is going to equal f of x plus h minus f of x all over h. What are we missing in this? Well, we are supposed to be taking a limit, and I did not write limit. So this is incorrect. This is a very common mistake, is to forget to write out the limit. So let's fix that. F prime of x equals the limit of that same fraction, f of x plus h minus f of x all over h. And what is going to 0? Something is going to 0. Remember that it's h. H is the difference between your 2 points. You're trying to get your points super, super close together. Another way to think about it is the denominator has to get close to 0, and so does this piece right here. So that is the function we are, or the limit that we are taking. Okay. So our goal is to figure out, for this picture of the graph, the goal is to figure out what is the equation of the tangent line. The tangent line touches our graph at this point, and it just like skims along the outside of it. It does not cross through. We want to know the point of tangency, which is 212, and we want to know what is the slope of that line, which it looks like a pretty high positive slope, so we kind of know what to expect there. So f prime of x equals that limit. We need to figure out what is f of x plus h. So we're going to do that off to the side like we did before. F of x plus h. So that guy is going to equal, instead of x cubed, we're going to have x plus h cubed. And then plus 2x is going to be 2x plus h. So everywhere there was an x in the original problem, you have to change it to an x plus h. We do some distributing now. So f of x plus h, you are welcome to pause that and do some distributing yourself. Here is the final answer with like terms combined and all of that. It's x cubed plus 3x squared h plus 3xh squared plus h cubed. So that all is just from x plus h cubed plus, and then distribute the 2x plus 2h. All of that right there is f of x plus h. Pause if you need some time on that. All right, let's bring it in. F prime of x is going to equal the limit as h goes to 0 of, so I'm going to put that whole big thing, x cubed plus 3x squared h plus 3xh squared plus h cubed plus 2x plus 2h. Looks like I need to zoom out, minus, so h goes on the bottom, f of x was the original function from up here, and that's going to go in parentheses. It was x cubed plus 2x. Alrighty. From here, we are trying to cancel out an h. You cannot just cancel out h's with h's that are in the original problem, because we have to cancel out factors, not terms, when you are doing the division, canceling from top and bottom. However, we can combine like terms across the top. Let's change this minus into a plus and change every sign that comes after it. Okay, so it's going to look like this, that plus, minus, minus. Okay, now we combine like terms across the top. X cubed plus negative x cubed cancels. 2x minus 2x cancels. And now you might notice that we don't have anything else that cancels. Hint, every single part of f of x is going to have a part over here that is going to cancel with it. Every single time. Both of these should cancel with something over here. And then all that's left is terms that have an h in them. So f prime of x equals the limit as h goes to 0 of, there's an h on the bottom. Let's see, from all of the terms up top, they all have an h in them. Let's factor out an h as we write this down. So this was 3x squared h. Now it's just going to be 3x squared because the h is on the outside. plus 3xh squared becomes 3xh. H cubed is h squared, and 2h becomes just 2. So if you plugged in 0, you would end up with a 0 times stuff over 0. 0 over 0 is indeterminate. So let's cancel out the h that was factored out with the h in the denominator. You are welcome to write out this step again with just the pink part and your limit, or you can go ahead and plug in at this point. F prime of x equals, let's plug in 0 every time we see an h. Okay, so we have 3x squared plus 3x times 0 is 0. Plug in 0 here for h, so plus 0 plus 2. Simplify that out. F prime of x equals 3x squared plus 2. There should not be any h's after you do the limit when you plug in that 0 for h. Okay, so in this case, the slope of the function is a function. Okay, it was not just a number this time. What that means is that the value of the slope changes depending on the x value. Which hopefully, oh, sorry, you can pause, write that down. The slope of the function is a function. The value of the slope changes depending on the x value. Pause if you need to. Over here, if we go to different points on our graph, we should be getting different slopes, right? This point right here has a different tangent line, and that tangent line slope is going to be different than the pink one, and the pink one's the one we are actually looking for. All right, so that was the entire problem of find the derivative of f of x equals x cubed plus 2x. Now we have to finish this up by finding the equation of the tangent line. Find equation of tangent line. So we need two things. We need pot and sot, point of tangency. So we need 2, 12. We were told the point of tangency. That's nice and easy. Next thing we need is the slope of the tangent line. To find the slope of the tangent line, that is going to be f prime, right? Because a derivative is a slope, so it's going to be f prime of, and we're plugging in 2. Well, we know that f prime of x is the function that we just got, the 3x squared plus 2. So f prime of 2 is going to be 3 times 2 squared plus 2. Careful, if that's a negative, you would end up squaring the negative, which would end up becoming a positive. So f prime of 2 equals 2 squared is 4, 4 times 3 is 12, and 12 plus 2 is 14. So the slope of that pink line, which is m, right? M is your slope, is 14. So the slope of your tangent is 14. These are our two pieces of information that we need. Now, I'm going to introduce a formula that you guys have definitely used before. It is called point slope form. Okay, so instead of y equals mx plus b, this is point slope form. It's y minus y1 equals m times, parentheses, x minus x1. x1, y1 is your point, and m is the slope. This reduces into what I call a skeleton form. So you're going to write this out, and then you're going to input the y value, the x value from your point, and the slope right there. Okay. So y1 is the y value from your point. It is 12. x1 is the x value from your point, it is 2. And m is the slope, which is 14. This can be done. That can be the equation of your line, EOT. We have found it. Now, I know that here early in the semester, you guys are like, that is an ugly equation of a line. You can, if you want, change that into slope-intercept form, and you can do that by distributing your 14. So I just copied. Distribute the 14, so we get 14x minus 28, and on this side, y minus 12. And then you can add 12 to both sides, and you end up with y equals 14x minus 16. So this looks a lot more familiar. This is also the equation of a tangent line, but you can just stop here. This is totally valid. I will be stopping here most of the time, but it's the exact same thing. The last little bit of our notes are centered around the alternate definition of a derivative. So we have a different definition of a derivative that looks almost identical to what we had before. The difference that we see here is that we have the letter C instead of X. So if we are looking for a derivative or a slope at a certain X value, so C is a particular value of X. It is a number. So we want to find the slope at X equals C. We instead have X go to C instead of X go to 0 or H go to 0 or anything like that. But if you take a look, that denominator ends up being, if you plug in C for X, C minus C, which is 0. And if you plug in C on top, F of C minus F of C is 0 as well. So the X values are getting really close together and the Y values are also getting really close together. Okay, so if you were doing like F prime of 2, like we did in the previous problem, this would be X approaches 2, this would be a 2, and this would be a 2. Okay, so you would still have to do your limit work, plug in f of x, so f of x would be the function itself, f of c would be the y value when x is c, which would be 12 from the previous problem. And then on the bottom it would be x minus and then 2. Okay, this definition is based on the definition for slope of a line. Okay, it looks really similar to f of a minus f of b over a minus b. Okay, the derivative is calculated slope between 2 points that are infinitesimally close together. I said the word infinitesimally correct and then the word close wrong. Good job, Miss Campbell. Okay, so that means like really, 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 really close together. So much that the difference between them is practically 0. The existence of the alternate form requires that the one-sided limits have to exist and they have to be equal to each other. Okay, we've talked about this back in Unit 1, right? We're going from the right side, we're going from the left side. Those two limits have to actually meet each other. So they have to actually equal the same thing. Otherwise, the function does not have a derivative at point C. So if the left and the right limits are not equal, then your derivative does not exist.